Hello guys, today we're just gonna go ahead and finish 2.1. We're gonna go over the second half. Now the first subject we're gonna go over is standardized Z-score. We saw this in 10th grade and 11th grade. Now back in 10th grade we actually used the table to determine the percentiles, and we actually did somewhat complex operations. As far as this chapter goes, all you have to do is describe how many standard deviations you are above or below the mean, and that's pretty much it. But let's go over the definition. Now, standardized Z-score for an individual value in a distribution tells us how many standard deviations from the mean the value falls and in what direction. So you can fall above the mean, below the mean, and how many. For example, after you do this mathematical operation, you end up with a value of 1.5. You are 1.5 standard deviations above the mean. If you are negative 0.9 after you finish this mathematical operation, you are negative 0.9 standard deviations below the mean. Now, again, right now you only need to answer this if you are above or below the mean and by how many standard deviations. But remember, in 10th grade we saw the normal distribution curve. Try to remember what percentiles were in each bracket, and again, for as far as the table goes, don't worry about percentiles. We might get into that later. So that's pretty much it for Z-scores. Pretty straightforward. You enter the value you are asked to evaluate, and then you subtract the mean from that value and then divide over the standard deviation of the sample or population you're given. So let's go over a problem that they give us in page 203. It says, find and interpret the Z-score for Jacob, who earned an 18 on the test. 1 second, I do have to find the other values. They tell me that the mean was 35.44 and the standard deviation was 8.77. So you just evaluate the target minus the mean divided by standard deviation, and you would be done. Pretty straightforward. Next, we're gonna go over what happens when you add or subtract a constant to an entire observation, or when you multiply or divide. Now, all you have to know is, in both instances, the shape will never change. The shape does not change the distribution. If you add a value or subtract a value, they are shift to the right or left, but the shape stays the same. If you multiply or divide, what you would do is more or less spread them out or bunch them a little bit more together. But again, the basic shape would not change. Now, let's go over the effects of adding or subtracting a constant. Pretty much, when you add or subtract a constant, the measures of center and location, meaning the mean, the 5-number summary, and the percentiles, they all get shifted or they move down from that particular value. Also, the range of the sample or population doesn't change, because you would be adding 5 to the top one, but you'd be adding 5 to the smallest measurement as well. So the range doesn't change. The interquartile range doesn't change either, and neither does the value of the standard deviation. Remember, standard deviation is a number. The measurements themselves will change if you add or subtract, but standard deviation will not change. If you multiply or divide by a constant, pretty much you multiply or divide the measures of center and location, meaning the mean, the 5-number summary, and percentiles all get changed by the proportion you're multiplying by, pretty much. And also the range, the interquartile range, and the standard deviation will be multiplied or divided by the number you're multiplying by. Again, pretty short video. That's pretty much for 2.1. Take care.